Fantastic. So let's get started by just going through and doing a bit of a review of each of the sections. So I'm going to hand over to Eryn to get us started with going through the computational art stuff, and then I will talk about strings, Eryn will talk about sound, and then I'll talk about the game dev section.
All right, cool. So throwing all the way back to our first day of the study group, I'm just going to be going over these. These are all the little lesson summaries if you're wondering where the heck these little reviews are. So if you're looking back later and you're like, oh, kind of don't remember something from this lesson, but I don't want to look through all of it, check out the lesson summary at the bottom first, see if it has the info you need. So we started off after this super duper basics of, what is a cell? How do we start typing? We started learning about variables and functions and how to use them. So we saw the basic syntax we use for functions most of the time is square brackets, but we can also use the double slash to apply a function after something, or the @ sign. So we've seen the @ sign, I think, a little bit more throughout the course, but those are other ways you can use functions. Most of the time, you're going to want to default to square brackets, though. In the first lesson, we also saw set. So if we have something, some variable we want to save information to, we can use set, which is just an equal sign, to save that to the variable. And then we can call that information anywhere else in our notebook. We also learned about set delay, so the colon equal sign. And that's what allows us to save a piece of code to a symbol, and that's going to reevaluate every time. So if I use set delay with something, say random color, and then I call color a whole bunch of times, it's going to give me a different color every time because it's rerunning this piece of code, which is then super useful when we get into writing our own functions. And so we've got that syntax here. We use set delay because then it's going to be reevaluating our right-hand side. And we want to remember our structure for the left-hand side, where we have our function name, f in this case, whatever variables we're using. In this case, we've just got one, and it's x. And then we want that blank to kind of indicate that it is one of anything, which we learned about a little bit later than this in some of the pattern stuff. Cool. I think I'm going to just go through all of these summaries, and then I'm going to take a little beat for questions after.
Totally. I just want to add, just if we go up one for a second, we got a great piece of feedback in the written review survey comments that we shouldn't be saying that random color will give you a different random color each time. It will give you a random color each time, which probably is going to be different to the one that you just had.
That is true.
But that's a little specific.
Yes.
But yes, random color will, in this case, give you a new random color each time.
Mm-hmm. Definitely. Cool. So after that, we learned about list, table, and map. So we learned a little bit about what a list is, which is represented with curly braces. I think we did a lot of stuff with lists that have all the same type of thing in it, but a list can have any type of thing. So we don't need to necessarily have it be all numbers or all strings. It can be a mix. We learned about the function range if we're wanting to generate lists of numbers. So if I do range of 10, it's by default will give me from starting at 1 up to whatever number I put in. And we also saw that we can add in a starting point, or we can also add in different step sizes. So we could have it go by 2 or by 3. We also saw 2 different ways to kind of iterate on expressions and create lists from an expression or a function. We saw that with table. So table, we give it its first argument. We give it something to repeat, usually with some kind of variable in it. So I squared. And then our second argument is the kind of whatever the variable is, and then whatever our bounds and other iteration parameters. So if we want to start at 0, if we want to start at 2 or 3, start at 2, and we'll go up to 5. And I could add another argument for step size, but I'm not going to do that in this case. So then if I run this, it's going to say, great, I'm going to put 2 in for I and run this, and then I'm going to put 3 in for I and run this, and then it does that a whole bunch till it gets to 5, and then we get a nice little list. We can also apply a function to every element in a list. So if we're already starting with a list, with the function map. So let's take this list here. I can use the function square root on it, and I can then map that. So our /@ is our shorthand for map. and then I can put my list and it'll get back to us. In this case, 2, 3, 4, 5. Map gets a little bit extra useful when we combine it with pure anonymous functions. So that's a way for us to make a function without needing to save it to a symbol. So we represent our variables with the slot, and we make sure we end it with an ampersand that tells our computer, hey, this is the end of the function. So I could do, if I wanted to re-square all of my numbers again, I could build a pure anonymous function like this. So it's going to slot into here with each of these numbers in the list. And I get the exact same output as I got from table, doing basically the same thing. Cool. And then for colors, graphics, and randomness, we covered a lot in this. So this is just a super brief summary of all of that. We learned about colors. So there's a bunch of built-in colors. Like, for example, we can just call blue and it'll give us a blue. We can also use RGB color and hue to create our own colors. So hue, we give it just a number. And it's got that kind of like sliding scale range from red looping all the way back to red. And we've got our RGB. I totally spelled it wrong right up there. RGB color where I can give it different. Just write this real quick. Hard to type and talk. If I give it the different values for red, green, and blue, it'll give us the color for those values. Cool. We also learned about graphics. And so graphics we're kind of building up. We start with small things like maybe we just have a triangle and then we add in another shape and we add colors and we add other styling and positions. So graphics, we can start super simple and build up pretty complex things. One thing we want to remember with graphics is that I'll do disk. Any styling we put in here applies to the things after it. So if I put red here, it's going to apply to this disk. And if I continue with more shapes, it would apply to all of those. If I wanted the disk to be blue, I could change it to blue. But I always want to make sure that whatever styling I want for our downstream parts of graphics are before them. Cool. And then we also learned about a whole bunch of different random functions. We just saw a second ago random color. There's also other functions that are useful that don't necessarily give us like a random thing of a type, like random choice. And random choice is going to give us, if we give it a list of things, it's going to pick one of them for us. Cool. And then last from this section, we learned about image manipulation. Again, we covered a lot of stuff in this. So this is just kind of a brief overview. But we learned about different ways to get an image into our notebook, copy and pasting, dragging from a desktop, example data image, natural language functionality. I don't believe we covered it in this lesson, but later on we saw how there's a function import, which works with a whole bunch of different types of information, including images. We saw how we can get the pixels from an image using the function data, and that'll give us a big old list of all of the colors for those pixels. And then we also saw in that lesson a whole bunch of different ways to start easily editing images, stuff like image crop, image compose, color negate, image effect, and even more than that. Cool. And so that was all that we kind of learned about on the first day.
So we're going to go through now the computational strings section, where we started out with string manipulation. So we covered some basics of string manipulation, and our big takeaways were how strings are presented in Wolfram, which is we would write them with our quotation marks, and then when we evaluate them, those quotation marks disappear, but it still knows that it's a string. So if I do head here, it tells me it's a string. It still knows even when the quotation marks disappear. We learned a bunch of functions for how to manipulate strings, and we learned that some of those have names similar to functions that work on other data, but they only work for strings. So for example, we have the function length. If we do length of range 10, it's going to tell me that it's 10. If I do string length of hello, it's going to tell me it's 5 because there's 5 letters in hello. Obviously, if I did length of hello, and tell me that it doesn't have a length because it doesn't do anything. There's nothing there. Yeah, so we do stuff like string length, and we have stuff like string take. We can have our hello in here, and we want the first 3 letters. We have things like string drop, which does the opposite of that. So if I want to drop the first 2 letters, and I get the last 3 there. And there are a bunch of other functions that work with strings. String template is one of my favorites. I don't quite know why it's one of my favorites, but I think it's fun. And string template allows us to computationally build up sentences. So with a little backtick. So every time that I see backticks, and then inside we have a word or a variable or whatever we want, then it will replace it. We build our little association here, and we say, I want you to replace color with red, for example, or we can do a rule delayed here. So for example, we could do random choice of red, blue, and green. And now every time I run it, it's going to give me a random one of those, either red or blue or green. Great. I love a good string template. They're a lot of fun. And obviously also we can put as many of those in as we want. So for example, and I'm just this is kind of dumb, but whatever. And then I could have adjective goes to cool, and now I keep going, and I can build my string template with as many things in it as I want. The next section that we covered were patterns and select. There's quite a lot in here. So patterns we can talk about. I think that the easiest way to gain an understanding of patterns is by looking at match Q, which is why we kind of start with that. So we can say, hey, match Q, is hello the same as something that can be anything? And it says, yeah, it is, obviously. And I say, okay, match Q, is hello something that has to be a string? And it says, yes, it is. And I say, well, okay, match Q, is the list 1, 2, 3, does that match the pattern? And I guess I'm moving on to the next bullet point now. Does that match the pattern? 0 or more things that can be anything, and then a 3, and then 0 or more things that can be anything. And it says, yes, it does. There's 0 or more things that can be anything here. So there's 1 and 2. And there's 0 or more things that can be anything after the 3, because there's 0. So that gives us our sequence of 0 or more things. So blank is the 1 underscore, blank sequence, 2 underscores, and that means 1 or more things in the pattern. And blank null sequence is a series of 0 or more things, and that's 3 underscores. So we get kind of increasingly more abstract, more general. Similarly to string manipulation, strings have their own set of pattern matching functions like string match Q, and those look for patterns within a string. So instead of just saying, yes, hello is a string, I can look for within the string, does hello match the pattern? 1 or more things that can be anything, and then I have to use my double tilde there to join up the strings, and then a double L, and then 0 more things that can be anything, and it'll say true. Yeah, so whereas if I tried to do that with match Q, it doesn't read inside the string. It just tells me that this is a string. Or that it tells me that this whole thing matches or doesn't match the pattern rather than within the string. Because we now have all of these outputs that have true or false, we can use functions like select and cases, and those we can use pattern matching and true or false statements to figure out if something is true. So for example, select will return for me all the elements of a list where the test returns true. So if I have my range 10 and I say, look at each one in this list and tell me if it's even. If it's even, it returns true. And so then select says, okay, I'll put that in the list. If it's not even, then this returns false. And select says, okay, I won't put that in the list. So then I get my even numbers from 1 through 10. Cases we can use, in a pretty similar way, and we can use more explicit pattern matching more easily in our cases. So for example, let's have two strings A and B in a list, and typing is hard, and three strings A, B, and C in another list. And I want to say, give me the cases where I have one or more things that can be anything, but they have to be a string. And then I have a B, and then there's nothing after it. And it says, okay, this one matches that pattern, and this one doesn't. So I'll return that one. Great. Now let's have a little gander at list manipulation. So Eryn just reminded us what lists are and how we can make them. So I won't also go over that. We can, a really useful function for lists is part, which allows us to get a certain part of the list. So let's say I have my range 10 and I want to get the fourth item in this list. That's going to be the number 4. If I want to get the fourth and fifth and sixth item, then I can use span, which is 2 semicolons, and it's going to give me the fourth, fifth, and sixth item in the list. I can also do this with negative numbers. I want the minus 2, minus second item in the list, and that's going to give me 9 because 10 was the last item in the list, and this is the one before it. And there's lots of other ways that I can use part, and part has this nice little double bracket, and that's pretty swell. Loads of other functions that we can use, like if I have my range of 10 and I want the first one, then I can do that. And notice how Eryn said that multiple ways to do functions. This is the same as that, and also this is the same, range 10. And if you're writing like real code, you should probably do this. If you're writing code like I'm doing right now, where I'm just showing a function or doing a quick calculation, then I personally do this a lot. I do this less. But yep, but good code should always be this. As this is the correct good coding style. But if you're just hanging about, then you don't have to do that. And other functions, last, we can do again stuff like take, range 10, I want the first 3, and stuff like drop, where I want to drop the first 3, easy. And I can do we can use part on nested lists. So if I have a list of numbers 1 through 10 and a list of numbers 1 through 12, so I have 2 lists, 2 nested lists in here, then I can do part to get the second one, or I can I can double layer this if I want the 5th thing in the second list, or if I want, you know, the third item from all of the lists, then I can do that nice and easy in there. We love it. We can rearrange lists in lots and lots of ways. So let's just get, if I just have, you know, a bunch of numbers that are not in any order, then yeah, I can do sort to that, and that will arrange them in nice order for me. I'm going to keep this list. Do I have any duplicates in here? Yeah, I do. Okay, that's fine. I can count the elements in a list with functions like count, counts, sorry, and with functions like tally, which will tell me how many of each thing I have. So this counts gives me association, and tally gives me a list of lists. So depending on what you might want, you could have anything. I can combine lists with something like flatten. So if I have this kind of list of lists, nested lists here, I can flatten them all out, which is pretty nice. I can also join lists together. So let's see what that does. See, that doesn't, sorry, the siren's going off outside. See, that's not going to do anything because I haven't asked it to join any of my lists together. But if I have just a series of lists, then those will join all of my lists together into one list. I can also do riffle. I love a good riffle when, you know, I have 1, 2, and 3, and I want to put blue spots in between all of them. That's very nice. I can split lists using partition and split and gather. So, you know, if I have my, let me just get my list of random numbers back before I started manipulating it. I can, you know, I can partition this into however many lists. So if I partition this into, you know, lists of length 3, then that's what I'm going to get. And split and gather will allow me to split based on what I have, and delete duplicates is a fun one too, where I can delete duplicates right here of this list, and then it gets rid of my 2 2s. Wow, that was exhausting, huh? Yeah, so that is a nice nice little range of things that we can do with lists. Let's see, Mark has given us a little example here of partitioning, which is nice. So for example, if I have, you know, 1, 2, 3, and 4, and I also have 5, 6, 7, and 8, then I can get so 2 and 4 gets me the 4th one of my second list. And we can also write that, let's see, we can also write that just with 2 and 4 right there if we want to be, if that feels easier to you to do that. Nice. Any other questions for this? So we had a question for string manipulation, the difference between string template and string form. That's an interesting question. Let's pull up real quick the documentation for string form. So string form prints as the text of the control string with the printed forms of expression embedded. Okay, so looks like potentially string form works in a, wow, it's kind of an odd way. I have not used this function ever, but it looks like it's just a way that you could insert a series of things into your little slots. It looks like you're not using an association to do that, which, in my opinion, means that you get a little bit less control. This is a lot less readable, I think, than a string template. But maybe this has more applications in the kind of math area than in the kind of text building area. Yeah, I would probably stick to string template for most applications.
All right, awesome. Now we are on to sound. Let me get that pulled up. All right, cool. So moving on to our sound day, we went over all the stuff related to the sound project. So first off, we learned about the function called sound and sound note. So how we can create sound objects using those. So sound and sound note kind of act like graphics in a way where you're creating kind of a list of you could create a list of notes you're playing. You could also play more than one note at once, but ultimately, whatever you put within your sound. And it's going to take a little bit to run. We'll give you a sound object as your output, and it'll be playing those notes. We saw how we can create a similar thing with the function play if we have an equation representing the waveform, which is the representing the frequencies of the audio. So we saw those two different ways to get a sound object like this one. We also saw audio objects. So if I wanted to take this and have it be audio instead, I could wrap the function audio around it. So we're going to take a second to run again. And now we have this different looking thing, which is a different way to represent, um, you know, audio stuff. This is specifically an audio object as opposed to a sound object. An audio object let us do a whole bunch of different functions to them. Audio trim to like cut off things at the start or end. Audio pad to do the opposite, add time on. Audio delete, which lets us edit in the middle of our audio. So if we've got, say, a chunk of our audio in the middle we want to get rid of, we can use audio delete. And audio split, which is going to let us take a piece of audio and split it into multiple pieces. So audio split is the only one of these four that's going to return multiple audio objects as the output. These ones will all give you one thing back. We also saw how to start analyzing these audio functions. So if I wanted to say, see what this looks like visually, I could use, we talked about audio plot, spectrogram, and periodogram. I think this is going to be pretty boring because it's just one note. But we can see what that audio looks like a little bit closer visually. And then we also saw audio local measurements. So this is a great visual representation, but it doesn't really give us numbers to work with. And so that's what we can use audio local measurements with. We give it a piece of audio, an audio object like this, and we pick some property. The property you're going to need in the mini project is RMS amplitude, and you can get the numerical data for that piece of audio. We also in this section learn about scoping constructs, which are not only important for the sound section, but also important for the game mini projects. So we learn about width. So if we have width with some things saved here, so we're going to do x is equal to 4, and then we have some expression using x. It's going to say, great, I'm going to ignore this global definition of x from earlier when I was talking about set, and I'm going to instead use this local definition to run this piece of code. I could add in more local variables into this list. and an expression that has those incorporated. One thing we want to remember with width is that we can't leave these unsaved. So if I do this, it's not going to know, I don't believe y is defined right now. So it's going to be like, what on earth are you doing? You can't just leave this thing undefined. It needs a value. If I did want to have this, where I maybe defined y here instead and separate it with a semicolon, I could instead use either the function module or block. So the syntax for module and block is very similar to width. Our exception is that we can leave these local variables undefined and define them later on. That's super useful if I, for example, wanted y to be dependent on x. I can leave it undefined here. And then over here, I could say that y is equal to 5x. It'll save this, and then it'll run the other part of the expression. We get a big old number. Cool. And then this is a note for those of you who are more curious about how things work on the inside. Just to remember that module and block do work a little bit differently internally. That difference between lexical and dynamic scoping. Not super important to know the details of that, but just to keep in mind that if you decide to use block, there's a small chance that it might return unexpected outputs as you're getting used to working with it. Because of how block is referencing the history of a variable as opposed to module, which is creating basically a new variable to be using locally. I think both Rory and I tend to default to module because of that, but I know other people who prefer to default to block. And there are some instances where you would maybe have a reason to pick one or the other. You're not going to really come across those with the kind of stuff we're covering in this course, so you can kind of pick which one you prefer. And then lastly, we talked about data analysis, talked about a whole bunch of different things here. We talked about how to get data in. So we talked about importing data. We could have our data come from computation like we do with the sound project. And we can also find data sets in the Wolfram data repository, which is super useful. We learned about time series to represent data that is time dependent. We did that exercise of how we can take a list of pairs with a time and a value, and we can make a time series, and then we can do time series specific operations on that time series. And then we also saw some of the statistical analysis that we can do with Wolfram Language and some visualizing data. And we also saw how to use the functions fit and nonlinear model fit. And that was kind of our little glimpse into data analysis. There is a lot more stuff you can do with data analysis than we covered in this course. So if that's something that's like interesting to you to look at after this course, I definitely encourage you. There's a ton of guides about it. And I believe there's even a whole Wolfram U course about data science and Wolfram language that you could also go check out after this.
Awesome. Fantastic. So we had a great question from Alex about using cases to do slightly more complicated things. So I am going to show us briefly how to do this. So Alex asked, how would I write code for cases of a list where the first element of a string is any string with string length 5, and the second element is a specific string? Now for this, we have to get just a touch more complicated. So let's say that I want to find world is my specific string and hello is my and I want to find all of the lists that the lists that end in the string world and start with something of string length 5, anything. So I'm going to need to use cases for that. There's probably a way to do it with select, but cases seems easier to me. And I want it to match the pattern, something that I've named specifically, and then world. And then I'm going to use this funky piece of syntax, which is a slash and then a semicolon, and that's called a condition, unless it's called a conditional. Nope, it's called a condition. And I want to get string length of A is equal to 5. So now it will test, it'll take each of these lists in, so this one and then this one, and it'll say, okay, does it match the pattern? This thing has a string length of 5, and the second thing is world. And I run that, and I get hello and world. So that's a slightly more complicated piece of code than what we cover in this course. But great question. Thank you. Okay, so let's run through now some of our big things from the game development section. So we covered first conditionals and writing our own functions. So we can use functions like if and functions like which. And let me just time check. Okay, we're gonna speed through this slightly. So we can use functions like if or which. So for example, you know, if hello, sorry, 1 second. So let's just set a variable. Let's have x is 5. Run that guy, and we'll have, you know, if x is 5, return 5, and if it's not, return not 5. Because we've set x to 5, we get our if is 5, and we get not 5. We can continue to use our ands and ors in our if statements to build up bigger and better things. But which is also nice and easy. So which takes the test and then the thing to return. So if x is 5, return 5. If x is 10, return 10. And if x is bigger than 100, return big number. And so then we can run, x is 6 right now, so it's not going to do anything. We can run x is 10, great, and then we can solve that problem by just putting in a true, not 5, not 10, not big. And now if I have 6, then I get it's not 5, it's not 10, it's not big. And we can continue to build and build and build our little functions. Our equal and same as we can use as part of our tests. So both of these are going to test if they have the same value. Same as will also check that the two items have the same head. So as we saw in the example, same as is going to give us false for this because this has a head of real and this has a head of integer. But they evaluate to be the same, so they are equal. And and or let us build more complex tests by combining tests into each other. So for example, if we had, we could do this right here, where we maybe let's set y is 2. So if we have x is 5 and y is equal to 2, then we'll do 5 and 2. And I did that incorrectly. But I'm sorry. You understand my point. We can pull in, this is for and, this is for or. So and will test if this is true and this is true. And if both of those are true, it will return true. Or will return true if this is true, or if this is true, or if both of them are true. So that's nice. We can also specify input requirements within our function definition. So for example, we can build a little function that says my input has to be a string, and then I can do style x red, and then when I do function of Rory, it'll print it in red, but if I try and do function of 1, it'll not know what to do. And then I can obviously continue to do that, continue to define it. So if I give it an integer, then it will just, let's just have it return X right now. So boom, now it just returns it. And then I can have this be whatever I want it to be. Boom, we love it. The next thing that we talked about was making and using associations. So associations, as we know, we make with these little buttons here. They need a key and a value. So if we were doing our favorite colors, we could do, Rory's favorite color is red. Eryn's favorite color, I don't actually know, so I'm going to make one up for them. It's going to be green. And now we have a nice little association that works real nice. Each key can only appear once. So if Eryn now tells me their favorite color and it was actually blue, then it will replace the Eryn goes to green with Eryn goes to blue, because we can only have one Eryn. Eryn is unique. Most of our functions will operate directly on the values of an association rather than on the keys. So for example, if I wanted to do string length to this, then it's going to give me Rory goes to 3 because red has 3 letters, and Eryn goes to 4 because blue has 4 letters. We can convert sets of data between associations, lists, and rules pretty easily. So for example, if I have my nice little association here, then I can make that into a list of rules by using normal. I can make it into a list of lists very easily as well. And you can find more information about doing that in that lesson. Dynamic, goodness, my time management today has not been as good as it has been in the last few days. So dynamic and manipulate allow us to create manipulatable objects and dynamic updating objects. Manipulate has a really similar structure to table. I think it's really nice to note that manipulate works exactly like table does. So if I have a table and I want to do x plus 5 and I want my x to go between 1 and 5, then we have my nice little 6, 7, 8, 9, 10, because we did 1, 2, 3, 4, 5 in here. And I can do manipulate with the exact same syntax, and it will create for me a nice little majigger, and I can keep going. If I want to do it a little bit more neatly, then I can do this and create my nice little slide, a nice little pop-up thing. This gives me an option of 1 and 5. And there are loads of other things that I can do. I can create my nice little slider, all of this kind of stuff within manipulate. Dynamic and dynamic module let us create dynamic output. Dynamic module provides more interface flexibility than manipulate does, which is always nice. So for example, if I wanted to do my let's think of a nice little example for dynamic module. So if I wanted to split my, so let me just make my nice little manipulate for this. So I want my x to go between 1 and 10 in steps of 1. Then I get my nice little slider. I don't know why my computer keeps turning off, and I'm sorry about that. Get my nice little slider between 1 and 10 in steps of 1. I can recreate that in my dynamic nice and easily with a nice little slider. So for example, I could do dynamic module, and the variable that I want to change is x. And what I'd like to display is a slider for dynamic x, and I'd like to display the dynamic output of x right there. Boom. And now I have my nice little slider right next to it. So I can create the exact same things that I create and manipulate, but I can get more specific. I can go down into the depths of manipulate to make whatever I want to make without being forced to kind of use manipulates outputs and layers. Within dynamic module, we use dynamic to indicate which parts of our code are going to be updating. So this little X right here. The very last one is event handling, and we talked in that one about
Rory, your screen is currently not sharing.
Oh, that's unfortunate. Okay, so this is what I was showing a second ago. So manipulate allows us to create these nice little sliders, nice and easily with the same syntax as table, and dynamic module allows us to it allows us to create manipulates in much more specific with more specific code to create manipulates in more generalized ways. We also covered event handling, which allows us to create kind of more complex interfaces. And I'm not going to get into event handling right now, but rule and rule delayed is a really important part of what we can do with Wolfram. A nice example of using rule versus rule delayed is exactly like set and set delayed, where we can use set to set a specific a pre-evaluated piece of code, and the set delayed allows us to set a piece of code to be evaluated each time, and rule delayed work exactly the same. So for example, if we had a range of 10 and we want to replace all of the integers with a random color, then that's my replace with my rule. So each time I run that, all of them will be the same random color. But if I change this to rule delayed, then all of them will be a different random color, because each time it sees an integer, it's replacing it with an unevaluated piece of code and then evaluating it, which is pretty swell. Event handler then allows us to use that syntax, allows us to use rule delayed to change something depending on the keys pressed or the mouse moving or whatever. So we saw this example before, where I can press my up arrow and it changes its size, and I can change my down arrow to change its color. And all I need to do is combine all of my skills into event handler to use dynamic and rule delayed to change the size and color. Awesome. So that took slightly longer than we were anticipating, but that's okay. There's a question: can you explain which and if with the documentation showing? Sure. We can pull up our documentation here. So if I look at if in the documentation, then it's going to say it needs a condition, and then what will happen if it's true and what will happen if it's false. So it gives the true value if the condition evaluates to true, and the false value if it evaluates to false. Whereas which takes a test, and if that's true, then it returns this value. Takes another test. If that's true, it returns this value. Another test. If that's true, it returns this value, etc. Keeps going. So just slightly different syntax to do a very similar thing. Can you use a button to change the color of an object in a graphic to a random color? Absolutely. If you look up the functionality for button, then you'll be able to see how to change the I don't know if there's an example for that, but yes, you can absolutely within the code for button change your graphics to a random color. That should be fine. Jim asks a question, how are multi-byte characters counted within length? I don't, off the top of my head, know the answer to that question, but I'm sure that it is in the documentation somewhere. And I recommend having a look in the documentation for something that specific. So what we would love to have you do now that you've kind of finished and understood a lot of what's been going on in the course is you should go and look at those projects and do the projects, watch those videos. The first 3 projects we have full solutions written out for you. We go through each step in the video. The last 2 projects, the video games ones, we want you to be as creative as you can be and come up with some amazing stuff kind of by yourself. So we don't have a video that takes you through each tiny step, but there is my full code at the end, which, so that you know, is code that's written very specifically to only use skills that you've learned in this course. So there are better ways to do it. There are shorter ways, more optimal ways to do it, but that code only uses the skills that you learned in this course. So feel free, if you have a higher level of Wolfram language, to make it more complicated, make it more optimal, anything you would like. And definitely feel free to get as creative as you can get with those projects.